Welcome everybody. Um, and again, you should be informed that this is a preparation for a philo birding field trip. So if you have already registered for a philo birding field trip, of which there are two, that's good. And this is a standalone thing anyway, if you care to. Right. So start with what is philo birding. It's just allowing phylogeny and biogeography to inform what you're seeing out on a birding trip. And that picture with the robin, that robin is pulling a phylogenetic tree out of the ground. That happens to be the logo of the Early Bird Project, which was instrumental in changing a lot of field guides about 15 years ago now. And the bottom one is a little map of the world as it appeared in the late Eocene. And that's where the biogeography comes into it. Right? So to start with something that you probably learned a long time ago, classification of organisms. We're going to skip the phylum, just start with class, order, family, genus, and species. And I want to shove another one into the middle there. Superfamily is just a bundle of families that are all related to each other in between family and order. That's going to come in pretty handy when we start talking about passerine birds. And just as an example here, the class we're talking about will be Aves, and within it there are many orders, including Passeriformes. The ending Eformes signifies that it's an order of birds, so all orders end in that. Superfamily Corvoidae is within the order Passeriformes. All superfamilies end in Oidea. Family Corvidae is within Corvoidea. All families end in IDAE, pronounced various ways by different people, but I go with the classical pronunciation of ID. Within that, there are many genera, one of which is Cyanocida, always italicized. And within genus Cyanocida, there is the species Cyanocida stellari, again, always italicized. And that is Cyanocida stellari. So I want you just to remember superfamilies, because we're going to get to those after a while, right? This is a phylogenetic tree of the birds. It's a phylogenetic tree of all the bird families that are found in the US, mainland US. And at this point, we should be assured that you know how to read a phylogenetic tree. First thing you should know is that the lengths of the various branches are arbitrary. They're just arranged so everything ends up smooth on the right side. Occasionally you'll see a tree where the branches are scaled to some sort of time, but that's not one of these. And the other thing you should know is that there is a root. That's the part. Can I get myself a pointer? Let's see if I can do this. Okay, so here's my laser pointer. This is the root of the tree down here. Trees can be shown right to left, left to right, top to bottom, bottom to top. You just have to orient yourself on the root. The root is the part opposite from all the names and these tips of the tree. And time, again, has no particular meaning, just that stuff over here on the left is older than the stuff on the right. So as we go to the right, we move upward in time, just not in any ordered way. Okay. And then every so often, the tree branches. and new branches are forming, and we end up with the various organization of branches at the tips. This is a tree, the same tree, except it's been expanded to show all the bird families in the world, not just the ones in the US. Um, for, for information, the US stuff is now shown in green. As you can see, what we have here is a fairly small sample of all the bird families of the world. And I see that I could fit this all on one page, one screen. I had to split this tree into 3 pieces in order to fit it all in one tree. And just for a little bit of orientation, this thing at the top here, that's the ratites and other related birds. That's phylogenetically, it's an entire half of the tree. Thank you again.
So tonight's speaker is Dr. Christy Phylo.
Okay, something's happening that's not good.
Scientist at Point Blue Conservation Science.
Somebody needs to stop that right now.
Just the critical work at Point Blue's Palomar.
All right, that's better. Anyway, I just like to point out that in terms of phylogeny, we do not see an entire half of the tree here. And for another point, here are 2 orders of birds. Remember, order is above family and superfamily. This one right here is Carassiiformes. There are 6 families in this order. We see only 1, the kingfishers. Right below it is another order of birds, the Pisciformes. There are 1, 2, 3, 4, 5, 6, 7, 8, 9 families in this order, of which we see only 1, woodpeckers. And if you look down here, more than half the tree consists of the passerine birds. As you probably know, more than half the species, more than half the families. The red arrow over here indicates where the start of the passerines is, and everything over in this part of the tree is a continuation of the passerine birds. So it's considerably more than half the species. But you will notice that there's not a whole lot in green. So a small proportion of the passerine families are found in the US. Here we have back to the US tree. And there's a couple families in gray. Those are ones that are introduced. The rest are native. Now I want to start talking about superfamilies. Because there's so many passerines, we need to chunk them a bit if we're going to be talking much about them. In color, there are a bunch of superfamilies, and I'd like to go through them one by one. Okay, the one in purple isn't actually a superfamily. I cheated. It's a larger group called a suborder, but close enough. This is the subacenes. Right? In around here, they consist only of the flycatchers and 1 species, the rose-throated becard, but they're really big elsewhere. The blue one is called Corvoidea. That's actually a superfamily because of the oidea. And around here, there are 3 families. That's the crows, the vireos, and the shrikes. Next, in kind of teal, we have the superfamily Sylvioidea. There are a bunch of families around here, of which I'm showing a wren tit. Swallows are another big one. Chickadees, another one. Down a bit, the one in green is the superfamily Muscicapoidea. And it's got a few families, most especially the thrushes and the thrashers. Next family is called Certhioidea. It has the wrens, gnatcatchers, nuthatches, a couple others. Fairly small as superfamilies go. And finally, the really big one, at least around here, is Passeroidea, which includes a bunch of families, including everything you think of as a finch or a sparrow, tanagers, all kinds of other things. And within that, there is another group which isn't a superfamily, but it's a pretty big bunch we're calling the New World 9 primary racines. You can see them in a bit of a deeper pink. They're going to be important. I'll tell you why later, but the name is pretty simple. New World, they're restricted to the New World. 9 primary means they have 9 primary feathers. The primary feathers are the flight feathers attached to the fingers. Birds do have fingers. And oscines just refers to half of the passerines, which is split into oscines and suboscines. New World 9 primary oscines. That's North America, the US. This is the same bunch of superfamilies spread out over the world. And you can see that there's a whole lot more families than are found in North America. Let's do a quick comparison. Right, on the left, the passerines of the world. On the right, the passerines of America. You can see that the suboscines in purple have one family plus a single species in the north. And elsewhere in the New World and the Old World, there are a whole bunch of families. The sylvioids, just a few families in North America, but a whole bunch of them elsewhere. That's the teal. The muscicapoids and the certhioids don't have a lot extra in other places in the world. They're pretty much similar. And you can see that the New World, the passeroids, most of the passeroid families can be found around here, but there's a little bit of expansion. Still, they're the only one of the big old world groups that's still big in the New World. Now we get to the biogeography part, and the whole rest of this thing is going to be about the passerines. Because they have so many species, there's more data that we can use to figure out the historical biogeography of these groups, which is why I'm going to be talking about them. So here's a map of the world as it was in the late Eocene. As far as we know, the passerines originated down in the global south, possibly Antarctica, because at this time Antarctica was not glaciated. The only fossils we know of were found in Australia, but at this point Australia was very close to Antarctica, so I'm giving some wiggle room there. At the very least, some movement has to have been through Antarctica if they didn't start in Antarctica, right? And these are color-coded. You'll see the color codings later. But you can see right here, they start in Australia/Antarctica. Fairly early on, one group gets into South America from the south. There's a fairly rare escape route from the south into Asia. That's the orange stuff right here. And from Asia, the whole rest of the world gets populated with passerines. Around here, comes out here. And there's a migration from North America down into South America also. So these are the main routes by which passerine birds have populated the world. How do we know any of that stuff? A little bit from fossils, but mostly from looking at the tree. This is, again, the tree of passerines, seeing where current families are found and extrapolating down the tree where their ancestors were probably found. And you can see here from the color coding, by the way, these are parrots over here. Parrots are the closest relatives of the passerine birds. They started out in Australia or, again, possibly Antarctica. When I say Australia, just think I may mean Australia and or Antarctica. But all the stuff that's from Australia is in red. So all the ancestral passerines start out in Australia. There are very few escapes from Australia. Most passerine families are still in Australia where they possibly began. Fairly early on, one little group of the subassines managed to find its way into Asia and went into a few places from there. Another group from the south got into South America. That's where all these purple things come from. Meanwhile, everybody's just having fun in Australia. A few escapees now and then, most of which didn't get out of South Asia. And right up here is the big escape event. One bird species found its way from Australia to Asia and diversified throughout the rest of the world. That's what we're going to be mostly covering here. Now a little detail. Okay, so first off, there's the subassines in red. Let's take a close look at those. Here's some pictures, just in case you need bird pictures. Right. Over here, this little branch here, this is the deepest branch of all the passerine birds. This bird is the relative of everybody else. That's the family Acanthicididae, the New Zealand wrens. This guy here is a rifleman. If you've been to New Zealand, you've probably seen them. Not going to say anything more about them. There's just two living species. Then we have the subassines. That's two groups. These are the Old World subassines. These are the New World subassines. The Old World subassines are in Asia and Africa, but surprise, one species, the Sapioa, has found itself in South America. Right? All these roots here are not the only roots. Somehow, some little bird got its way from Africa into South America, and he stayed there. And this is the broad-billed Sapioa. He's an Old World subassine in the New World. Meanwhile, the New World subassines, again, which came from the south and spread throughout South America, they come in huge variety. If you've been to the neotropics, you've seen a lot of them. Ant pittas, ant birds, cock of the rock here, titiras, all these guys, New World subassines. One family manages to get into the US. That's the flycatchers, Tyrannidae. There is a second family, which the titiras. The rose-throated Becard is technically a bird that gets into North America. You may even have seen one, but most of that diversity is still in South America. Most of the flycatchers are still in South America. Next bunch isn't actually a bunch. It's just a number of branches that started in Australia, still in Australia. Just want to briefly show those. There is a fairly large superfamily in there that I'm not covering much because none of these made it out of Australia. That's Mellophagoidea, which includes the honey eaters, the fairy wrens, and a bunch of other familiar Australian passerines. These are all mellophagoids over here. This group includes it's not a group, it includes the bowerbirds right here. It includes the lyrebird, magnificent lyrebird, and Abert's lyrebird. But again, all these are found in Australia. And when I say Australia, I should mention that I mean Australia and New Guinea, because New Guinea is geologically part of Australia. Right? Australia has its own private bird fauna. That's really just all the birds that have not made it out. Okay. Here's a big superfamily, Corvoidea. As you can see, most of the corvoids are still in Australia, but a few have made it out, some of them just a little ways, some of them a bit farther. The vireos have made it to Asia and out to America. Right. The crows made it to Asia. Some of them got to America, but they originated in Asia. Same with the shrikes. Right? So we have three families have made it to America out of all the bunch of families in this large superfamily Corvoidea. Here's another intermediate group. This is everything between the corvoids and the next big group. They're not a group themselves, they're several groups, but again, mostly they're in Australia. They haven't made it out of Australia. Most notable among them, the Australian robins. If you've been to Australia, you've seen a lot of those. There's one family that originated in Africa. How they made it to Africa is unclear because there's really nothing in between Australia and Africa that would link them. But these were the rock fowl, very rare fancy birds that I have never seen, but if you've been to the African rainforest, maybe you have seen some. Okay. But here is the big event in biogeography. At some point, again, one species made it out of Australia into Asia and gave rise to most of the passerine birds of the rest of the world. The red arrow is showing where this happened. It was somehow by this route. And when it happened, right, the distance between Australia and Asia was greater than is now. So it was definitely a difficult route to follow. But they made it, and all of these birds here, the four superfamilies we haven't talked about yet, all come from that one origin. And let's first talk about the biggest of the superfamilies, Sylvioidea. As you can see, none of the Sylvioid families originated in America, except for one species. This is called the Donacobius down here. It lives in South America, but none of its closest relatives are anywhere near. They're all in Africa. Possibly it followed the Sapioa on the same route. The rest of the families, the core of Sylvioidea is in Africa and has been in Africa. Some of them got to Asia, and some members of the families in blue managed to make it into America. In America, there are 7 families with at least one species in the US, but only 2 of those families have more than one species in the US. That would be the chickadees and the swallows. Every other species, every other family has a single species. Not fitting the Donacobius, but these are all the other families of sylvioids found in the US. And I apologize, this slide is fairly old. The wren tit is the only member of its family in the US, but that family has turned from Sylviidae to Paradox ornithidae. We'll see. The bush tit is the sole American member of the Old World family Agathalidae, the long-tailed tits. Arctic warbler is the sole American member of the big Old World family Phylloscopidae, the leaf warblers. Horned lark is the sole North American representative of a giant family, Alaudidae, the larks. And the verdin is the sole North American or American member of an Old World family, Remizidae, the long-tailed tits, or sorry, the penduline tits. Just to check it out, Sylvioidea, which used to include Paradox ornithidae, has 69 species, of which we have 1. The winner, though, would be the larks, which have 93 species worldwide, of which we have 1. Why is this? I don't know. Another interesting thing about it, though, is that most of these families with one species, that species is found in the southwestern US. Right? So, the Arctic warbler is at least close to Asia, where the whole family comes from, but those other 3, they're very far away from Asia with no intermediate groups. And I don't know why. A lot of the biogeography here is going to be mysteries of biogeography. All right. On with the superfamilies, Muscicapodea, Certhioidea, and another one that I haven't talked about because there's no room to print it on the slide, are all related to each other. The one that wasn't room for is Bombyciloidea, which is a weird one. I want to talk about Muscicapodea. So Muscicapodea, again, originates in Asia, but there is one family of Muscicapodea that is found only in America. That's the thrashers. Couple families originated in Africa. These are the oxpeckers, which I, for some reason, didn't give you a picture of, but hope you know what an oxpecker looks like. And those are the starlings, which are really big in Africa, not so much in other parts of the world. Of course, we have 1 introduced species. Certhioidea, I'm not going to talk about that further in particular, but it's there's a lot of New World certhioids. There are 2 families that are originated in North America. The wrens are the big one. And here's a reverse point, right? A lot of sylvioids have 1 species in America. There's 1 wren species in the rest of the world and many, many in America. So things go both ways. And finally, Bombyciloidea. This is a bombyciloid, a silky flycatcher. We have two species of Bombyceloidea here in North America. Well, three, I guess, if you count the two waxwings. And then there are four species of silky flycatchers, of which here in the US we have one. Some weird biogeography again. This is on the genus level. The genus Turdus has 80 some species, of which here in the US we have 1.5, say, right? We have the ubiquitous American robin, and there's also clay-colored robin that barely gets into the US. But in the rest of the world, or most of the rest of the world except for Australia, there are many species all over. The little circles tell you how many species there are in any particular region. 14 species in the Caribbean and Central America, 26 in South America, 14 in Africa, 6 in Europe, 14 in the north part of Asia, 10 in the south part of Asia. So they're all over the place, except just one here. And that always puzzled me. I had no explanation for it. A couple years ago, there was at least a partial explanation. But I find this pattern fascinating and weird. Turns out that the Caribbean and Central American species of Turdus, first of all the New World species of Turdus come from a single ancestral species that found its way to America. And that route was apparently from Southern Europe to the Caribbean. And all the Turdus of the New World spread out from there. For some reason, they didn't go north, possibly because they're tropical or subtropical species. But that's at least a partial explanation. The entry point was not, as with most birds that get to America, across the Bering Strait or from the east. It was across the Atlantic from somewhere in the vicinity of Spain. On to the weirdest biogeographic thing I have for you here. Bombyceloidea is a superfamily. It's got 6 families, but only 13 species. Here are the families. Bombyceloidea, the waxwings, has 3 species. That's what the 3 red dots are for. The silky flycatchers have 4 species, most of them in Central America, and of course 1 in California. Then it gets a little stranger. This is the palm chat. The entire family is 1 species found in Hispaniola, nowhere else. This is the hypocoleus, 1 species found in a limited range in the Mideast. This is the Hylocytrias, 2 species, both on the island of Sulawesi. And finally, the mohoas, 2 extinct species formerly from Hawaii, thought to be Hawaiian honeycreepers for a long time until somebody looked at some fossil DNA. But this is the superfamily. It's got only 13 species, but it's spread throughout the world, mostly on little islands that you've probably never visited. Again, no explanation for how this happened. I just point to it as something really weird and interesting. Final superfamily, Passeroidea. The red arrow indicates the New World 9' asines, remember them? So Passeroidea originates in Asia, includes lots of species that you have seen if you've gone to anywhere in the old world. So, God, well, sunbirds, really big family in the old world. Um, the weavers, big in the old world. Um, there's no the Australian finches, big all over the old world, including Australia. So again, these arrows here, they do sometimes go in both directions. Some of the Asian families have managed to get to Australia. The Australian finches are one. Old world sparrows, um, the family usually just called finches. One I want to mention, this is the olive warbler. It's not a warbler. It's a family of one, and it's this bunch right here, Pusidrammidae, right? Nested within a whole bunch of Asian families somehow. Again, somebody managed to get to the American Southwest. No one knows how or why, but it's isolated from everything else. This is the New World 9 primary dacenes. Oh. And PowerPoint just quit on me, so allow me to start it up again. Am I still screen sharing?
So you are not currently screen sharing anymore.
Okay, so I'm going to have to set the whole thing up again. I hope it doesn't really cause problems. Computers. Can't live with them, can't live without them. And coming up, by the way, is the last slide. So all this is just to get us to the final.
Always kicks out at the very, very end.
Carolyn, should I play the harmonica while we're waiting?
Only if you're willing to play non-copyrighted music.
Okay. Has the screen sharing worked? Yep.
Not yet.
Yeah.
Okay. Oh. I have to screen before I start this thing. Okay, come on. You can do it. I'm assuming you can do it. Yes. Okay. Can we see it now?
Yes, we
Yeah.
can.
Beautiful.
Hooray. I'm not going to bother starting the slideshow because weird things could happen. I'm just going to go to this last slide. This is it. All right, so this is the superfamily Passeroidea. As you can see, they get their start in Asia. At some point, my pointer is turned into an arrow. Can you see the arrow?
Yes.
Okay, so at some point, one of them gets into North America, where it starts turning into the New World 9 primary dacenes. As you can see, some of them manage to get back into the Old World. But most importantly, one big bunch gets into South America and goes crazy. This gives rise to the second biggest family of birds, the tanagers over here, and a bunch of others, including the New World blackbirds, the New World warblers, the cardinals. So here in America, the New World 9 primate arcenes are fairly dominant in terms of passerines that you'll likely to see, right? So all the sparrows except for the Old World sparrows, all the warblers, all the cardinalines, all the blackbirds, those are New World 9 primary dacenes. And that's the end of this presentation. I open it up to questions.
Uh,
Folks, you can either write your questions into the chat or just unmute yourself and ask.
yeah, I got a question, John. So with some of these outliers, these mysterious birds, and I have to say the mysteries are what are most intriguing to me.
For sure.
What's
Me too.
what's the path of research that's going to help shed some light on these mysteries? Are you looking at fossils, or are you looking at genetic readings, or what?
Bird fossils are not particularly common. And when you find them, you generally find them in limited areas of unusually good preservation. So that's not going to help us a lot. What you need is the data from the distribution of living birds. And when you have the one isolated species, the distribution of living birds isn't going to help you a lot. So this is a mystery that we probably can't ever solve.
Oh, that's disappointing.
Yeah. But yeah, if it was going to be solved, it would be solved from fossils. But good luck finding a fossil locality. The other problem with fossils of passerine birds is that there are very few differences that get preserved as fossils that can enable you to identify the different groups of passerine birds. So right there, they skeletally, they mostly look alike.
So I have another question, if it's okay. That single mysterious bird that ended up in South America.
The Donacobius.
Oh no, it began with an S, I think.
Oh, the Sapioa.
Yeah. Yes. So I know I'm asking you to go out on a limb, but what's your personal theory about how that mysterious outlier ended up here?
Oh, I forgot there is one other piece of evidence that might help us a little bit on this. Just want to find the Sapioas for you. Where am I? There I am. Oh, right. So here's our friend the Sapioa. You notice his relatives are in Africa, Africa and Asia. So my theory would be that, as in a couple of other cases, somebody made it across from the closest approach of Africa to South America. And the Sapioa is found on the East Coast, so that helps us think that might be true. Another thing that can help us that I forgot to mention is you can estimate how long ago something happened based on the difference in the
A kid who likes birds.
somebody's. We're hearing Vicky. Anyway, you can estimate how long ago something happened based on the differences in DNA, and then you can start to look for some kind of event that happened at some time that might produce commonalities, at least among different species. For example, a bunch of mammals appeared in South America, probably from Africa in the mid to late Eocene, possibly all at the same time. So you think there's some common event that did that. And it's conceivable that the Sapioa came over as part of that same event. But you'd have to try and calibrate this tree to some particular date to see if that's true.
Yeah, oh, that's fascinating. I could see a follow-up to this presentation because this is sort of the end of a lot of research. I'd like to see at some point a summary of how the research is done.
Oh, I actually have a presentation on that I've given for the Audubon Society before.
Yeah, I'd love to see that again.
Okay.
At some point.
Of course, that was stuff that was done, let's see, now, 15 or so years ago.
Yeah.
And it's
some things are probably
fancier now.
Would love to hear an update on how that research is done and yeah, fascinating.
We could get into that. And I should point out that all the trees we're seeing here come straight from DNA.
Yes.
Nice.
Well,
Okay.
you've unintentionally kind of answered my question. I was wondering if anyone had looked into any potential correlations for moments of intense speciation or even just movement
Mhm.
and the timing of large-scale climate changes.
There,
Um,
there have there have been a number of attempts to correlate, yeah, speciations and or movements with world events of some sort or another. Um, Offhand, I can't think of anything that convinced me particularly. It all has to be speculative because, right, the kind of data we get for these just tells you that two things happen at the same time
yeah.
within a few million years of each other. And I don't know if that's good enough for you to be confident in the approach.
I think it's fascinating to think about what the globe looked like in our early history,
Mm.
and then imagine that some of these journeys that look like they're so long might have been shorter at the time.
Mhm. Or longer also
Yes,
at the time.
yes, of course.
Right. If you'll notice on the map here, Australia again farther from Asia than it is now,
Hmm.
um, which there are very few migrations from Australia to Asia back around this time. And there are some others that have happened that are much more recent and have not spread extremely far for that reason. If you remember, there's my tree here. Um, you see all these little yellow branches here in Corvoidia, right? Most of these yellow branches get into South Asia and no farther. And my theory would be that they are more recent events that haven't had time to spread, whereas a couple of these others, like the ones with the names in blue, some of them have managed to get all the way to America,
Hmm.
right? Presumably older. And again, the branches here are entirely arbitrary, so
Right.
don't go figuring out what's older from this.
Yeah. All right, John, we've got one of the hardest questions a birder can be asked. What
Okay.
is your favorite bird?
Oh, um, my favorite bird varies from moment to moment, obviously. Um, but let's see. I can't even pick one right now, but I'm going to say ruddy duck is my favorite bird because they're so cool. Um, and I did ducks for my PhD. But I'll also say that my favorite bird is shoebill because
Mm,
I'm a month from now I'm going to go look for them,
wonderful.
and they're just weird.
Yeah.
Yeah, that's great.
This is Dory. I'll be on the trip with you on Saturday. And I was wondering if you could talk a little bit more about how you apply this type of study to actual birding in the field.
Right. So um, the first thing is to just there are these various weird facts that come up when you look at a bird. Some of which I have mentioned here. Right. So you see a waxwing and you say, "Whoa, that's a bombyciloid," and they have this bizarre distribution with only 13 species across the world. Um, the other thing is it's just nice to know when you're looking at, say, a robin, that it's our sole representative of the genus Turdus, first off, and the genus Turdus, right? You should know the thrush family, so you know its relatives are thrushes, of which we have a fair number here. Um, but then you go outside that, past that, into the superfamily Muscicapoidea, and you look at a starling, and you say, "Oh, that's related to a robin," and you see a mockingbird, okay, which is a thrasher, and that's related to a robin. And you see a mockingbird, you could also say, "Oh, the mockingbird are close relatives to the starlings," right? So I just think the structure of relationships among birds is in itself fascinating. And the distributions through the world of species, families, etc., is fascinating itself. So when you see a particular bird, phylobirding puts that bird into its context. That's what I find interesting about it.
Yeah, sort of giving a historical context for
Yeah.
that bird on a geological scale.
Right. That's the idea. And there are things you can get out of that too. Like if you know that the starlings and the thrashers are relatives, it becomes clearer why they both have this wide variety of songs and are constantly changing their songs. Right? That's apparently something they get from their common ancestor. So there are various characteristics of a lot of these birds that make a whole lot of sense when you superimpose the tree on them.
Fascinating. Awesome, John. Thank you so much for sharing all this with us tonight. One last moment. Does anybody else have any lingering questions?
No, but I want to thank you, John, for sharing your knowledge here and leading the trip that you're going to be leading on Saturday. And I look forward to a future presentation about how the research is done. So thank you very much. This is great.
Right.
Really learned a lot. I appreciate it.
Thank you. And I'll see some of you in a few days.
Thank you, John.
Bye.
All right.
Good night.
Thank you all. Have a good evening.
Thank you, everybody.